Hello my friends. I would like to title this video The Language of Computers, and in it I'd like to address and correct a common misconception concerning the language of computers. So many of you, if not all of you, have probably at some time or another heard the phrase binary is the language of computers. And I would like to tell you unequivocally that that statement is false. Binary is not the language of computers. Now, that's not to say that binary has nothing to do with computers, or that computers have nothing to do with binary, but a more accurate statement would be that binary is the alphabet of computers. Let me explain. Consider these symbols that you're quite familiar with at this point in your life. These symbols do not represent the English language, nor do they represent the Spanish language, even though we know that both languages utilize these symbols. Arranging the symbols THE, thusly, gives us the English article the. However, if we want a similar meaning in Spanish, we'd have to reach for a different set of symbols, E, L, and A, and we could arrange them as L or La in order to get a similar meaning. So we've got, in this case, different symbols arranged in different ways to get a similar meaning. The symbols NO could form a negative response to a question in English, and it turns out that they could be used in the same way in Spanish. On the other hand, if we would like to answer in the affirmative, we would reach for the symbols YES in English and SI in Spanish. So, again, we see the same symbols being used, but in completely different ways in these two languages, English and Spanish. The reality is that the symbols A, B, C, D, and so forth do not represent the languages English and Spanish. Rather, they're what we refer to as the Latin alphabet, which is leveraged by numerous languages, English and Spanish just being two examples. The same situation applies to computers. So consider that we have two computers, computer A and computer B. Computer A is utilizing a processor or CPU of type X, and computer B is using a processor or CPU of type Y. The CPU, or central processing unit, is kind of like the brain of the computer. It's the thing that processes data and instructions for us. Both of these types of computers utilize the same alphabet, binary, or 1 and 0. Now, these symbols 1 and 0 could be physically represented in many different ways inside of the computer, as electrical signals, as magnetic polarities, as different kinds of light, and so forth. But ultimately, we'll represent all of those things as 1 or 0, and ultimately that's how we'll interpret those different mediums that we're using to communicate inside of a computer. A 1 or a 0 is ultimately what it'll come down to. Now, it could be then that this set of 1s and 0s, when presented to computer A as an instruction, have the meaning add, while that same set of 1s and 0s might mean nothing to computer B, or computers using CPUs of type Y. At the same time, this set of 1s and 0s might mean multiply to a CPU of type Y, and might mean nothing at all to a CPU of type X. On the other hand, they might mean something completely different than what they meant to CPU Y. So we see here that a language is not merely an alphabet, but an alphabet combined with a set of rules. We often refer to those rules as the syntax of the language. Okay? The rules that you have to follow to write a valid statement or communicate in an effective way when using that language. And if you don't follow the rules, you end up saying something that means nothing in that particular language. Or maybe you say something that has meaning, but not the meaning you intended. So with this in mind, we might ask ourselves, well then, what actually is the language of a computer? And the language of a computer is called machine code. And as there are different kinds of computers, there are different kinds of machine codes. Two examples would be the x86 and ARM families of processors. Very common processors in the world today. So If you were to look inside of your laptop or your desktop, you're likely to find an x86 type processor. Whereas if you were to look in your mobile device, such as your cell phone or your smartwatch, you're most likely going to find an ARM style processor. Both use the alphabet of ones and zeros, or a binary. But they recognize and respond differently to different sets of ones and zeros. They have different machine codes. So why do we care? Why do we care what the language of a computer actually is? Well, for several reasons. For one thing, understanding what machine code is and the fact that there are and were many different types of machine codes can help us to understand the challenges and problems that early programmers had to deal with. Subsequently, we're better equipped to understand the solutions that many brilliant men and women came up with to overcome those problems or make it easier to work with modern computers. Additionally, understanding that binary is the alphabet and machine code is the language can also help us to understand problems that come up when we're trying to program computers, whether it be trying to understand mistakes we've made on a specific type of computer or problems that are arising when two different types of computers are trying to communicate. And so this isn't just an exercise in splitting hairs in terms of the meaning of words. It's actually a fundamental concept upon which we can build as we learn how to program computers in general. And that's what we'll start to do in the next video. Until then.